Yeah, comes on everyone. Let's start off. This is the last thing that we did. Great. Let's go ahead with more problems. Perfect. So we have two blocks here, mass m, 2m, spring constant k, smooth ground. You gave speed u to this block, and this block is at rest initially. Find time period. I hope everyone remember this. We have done this in center of motion momentum. Find oscillation energy. Find the amplitude of each block. Let's get there. How do we even start this? So look at this thing. Now, when you push this, the block M and block 2M, their speeds will keep on changing. Agreed? Now, for more analysis about this, you should definitely go here. Center of mass momentum. And there, if you remember there, this was a problem 30. We did a pretty detailed analysis on this thing. Do you remember this? So we wrote total, this 8 states. So this will follow a cycle like this. You should definitely go through this in case you forgot. So how will the blocks move? What will happen to the speed? Blah, blah, blah. We did a lot of stuff on this. So this is page 112. right? So block M ka velocity will change, block 2M ka velocity will change, but there is someone who is going with constant velocity. Who? There is someone who is going with constant velocity. Anyone? Who is that? Center of mass. Perfect. Since the external forces are zero, the center of mass will continue to go with the same velocity. So this is going with M. This is going with 2M. Your center of mass will be somewhere here. This will go with velocity of center of mass is M1 U1 by plus M2 U2 by M1 plus M2 U by 3. So here if you see center of mass is an inertial frame. It has no acceleration. That means I can go and stand on the center of mass and do the problem. So now if I go and stand on the center of mass, what will the center of mass think? Center of mass will think, okay, I'm not moving, so I'm like a wall, and the other two blocks are like connected to a spring. And we know the center of mass will divide in the ratio of 2:1. So this length will be 2L by 3, and this length will be L by 3. And when you cut a spring, what is the spring constant? This will become 3K by 2, and this will become 3K. Isn't this how it looks? When you stand on the center of mass, it feels like you have cut the spring, and this thing has become like a wall. And the center of mass will think, okay, it's like simply two blocks and two springs, and both are independent of each other. And now if you want to find the time period for one spring and one block, it is 2 pi root over m by k. Mass is m and 3k by 2. Interestingly, you'll observe you'll get the same answer for both. You can take the other spring also, get the same answer. You should get the same answer because they both belong to the same system. Is this making sense? Easy? So if you go and stand on the center of mass, you cut the spring. And if you cut the spring, you know the spring constant. Is this clear, everyone? This is a concept, Ansh. What you're saying is a shortcut. So this is one. We will see. There's a faster way to do this in the mains exam, but we will see that. Let's go ahead more. Now, if you ask the center of mass, now remember, you're standing on the center of mass. So if you go and stand on the center of mass, what will the center of mass think? Center of mass will think this guy is coming with 2u by 3, and this guy is coming with u by 3. This is with respect to center of mass. Do you agree? And remember, the spring is in natural length. That means this is the mean position. And if this is the mean position, that means these are the maximum speeds with respect to center of mass. That means this is the maximum speed with respect to center of mass. That means if that is the maximum speed, then this should be equal to A2 omega. Therefore, A2 omega is u by 3. Similarly, A1 omega is 2u by 3. From here, I'll get the amplitudes of both the blocks. A2 is u by 3 omega. A1 is 2u by 3 omega, where omega is nothing but root over 3k by 2m. Got the amplitudes? So if you go and stand on the center of mass, you will think these are the velocities and these are the maximum velocities, isn't it? Because the spring is in natural length. If the spring is in natural length, force is zero. Force is zero means it's a mean position. So going and standing on the center of mass will solve your problems. If you try to do this in the ground frame, it becomes really difficult to observe what is happening. But center of mass will give you the thing. Is this clear, everyone? This is how you do the problem normally. Now, instead of taking m and 2m, if I take m1 and m2, means same thing, same concept, but if I use masses m1 and m2, any doubts on this page? All clear with this? Arnav, Taksha, clear with this? Sharman, Arush, adjust your camera a bit, can't see you. Soham. So, this is the shortcut. So if I take m1 and m2, same story, you go and stand on the center of mass. Then the time period of this is given by 2 pi root over m1, m2 by m1 plus m2 by k. This we write as 2 pi root over mu by k. Mu is your reduced mass. Remember this? We did this thing even there also. So reduced mass, right, is not a concept. When you take the blocks as M1 and M2, and when you try to solve the problem with the center of mass, you'll get this answer. Since this thing looking like mass car term, we said, okay, this is looking like mass car term, we call it reduced mass. Are you getting it? So reduced mass is a concept which you get it when you do in the center of mass frame. So if this comes in the exam, this saves you time. You'll get the answer in one step. But how we got this? This is the process. Any doubts on this? Question is still not over. Find the oscillation energy. How do you find that? So total energy and oscillation energy. We had a discussion about this. Now see, you can get it in two ways. One, let's go back to the definition of oscillation energy. What is the definition of oscillation energy? The energy which converts from potential energy to kinetic energy, and kinetic energy to potential energy. It's like if you have 1 lakh in the bank account and 10,000 is the minimum balance, the 90,000 is convertible. The 10,000 you can't do anything. If that is the argument, initially, what is the spring energy? 0. What is the maximum spring energy? Half k x max square. That is your maximum you can get, right? You can't get more than that. That means that is the oscillation energy, right? The energy which converts into kinetic energy to potential energy to kinetic energy. Initially, your potential energy is 0. The maximum potential energy is half k x max square. That means that is all the energy that converts into kinetic to potential. That is one way to argue. Another way to do this comes from rotation. Maybe have this statement if you remember. Kinetic energy of the system is kinetic energy of center of mass plus kinetic energy about center of mass. Do you guys remember this? Now, in this statement, if you see, this is constant. This will be half total mass. So this guy is half mu square. That is the initial energy. This will be half 3 m v COM square. And if you observe, this is your constant energy. Getting it? So this is kind of looking like you mean. So this component is what is changing from kinetic to potential and potential to kinetic, isn't it? What is the total energy of a system? Total energy of a system is oscillation energy plus u mean, isn't it? Is that making sense? So you can divide energy into two components, the kinetic energy of center of mass, kinetic energy about center of mass. Center of mass, the velocity does not change, so that is constant. That means only this component, this component, right, changes from spring potential to kinetic energy. This changes from spring potential energy to kinetic energy, and then kinetic energy becomes spring potential energy. So from here we get oscillation energy will be the total energy of mu square minus half 3m VCOM is u by 3 whole square. That would be half mu square minus 1 by 3, that is 2 by 3, 1 by 3 mu square. Are you getting the meaning of oscillation energy? Tell me one thing. Will the blocks ever come to rest? Will the blocks ever come to rest? Both the blocks at the same time, will they ever come to rest? That's not possible. Why? Momentum conserve nahi hoga. If both the blocks come to rest, momentum becomes 0. Initial momentum is mu, momentum is not conserved. That means there is always some part of the energy which is left over, isn't it? Which cannot get converted into spring energy. You can't write like this, na? Half mu square is equal to half kx square. This will never happen. Because there is some part of the kinetic energy which is always left over. Matlab, the remaining energy is getting into oscillation energy, isn't it? Is that argument making sense? So you could have also said like this. So max spring potential energy is oscillation energy. And max spring energy is nothing but half k x max square. And half k x max square is nothing but half mu v relative square, where mu is m1 m2 by m1 plus m2, and v relative is v1 minus v2. Again, we saw this thing in the same problem. This is the shortcut I taught you, remember, in the red box. If you have a block m1, m2, u1, u2, the maximum compression of kx max square is this, which is half mu v relative square reduced mass. So definitely refer this in the notes. Saves you a lot of time in the exam. This is how an advanced paragraph will look like. So I can ask you maximum compression, I can ask you oscillation energy, I can jump between central mass collisions to SHM. So the whole problem is jumping between two chapters. So refer the whole problem once, it's a pretty good one. If you see in this problem, I even asked more questions, maximum speed of 2m, minimum speed of m. This could be a matrix matching actually. There are almost 6 to 7 questions that I could ask you in this. Any doubts on this? So oscillation energy is one important thing, generally neglected term. So be careful. Total energy, oscillation energy are not same. Next thing. Any doubts on this? Clear na, Purja? Chainil, Arya. Next one. We have a spring M K K K. This is theta and this is theta. Find time period for small oscillations. Why small oscillations? I don't want the angles to change. So for small vertical oscillations, so you pulled it up and down. So you need to understand why sometimes small is written, sometimes it is not written. If you pull too much, angles will get messed up. We don't want that. Maybe they will change from 60 to 59.9, something like that. So negligible change. How do you do this? This is a standard equation. How do we proceed with this? Think, take a minute. If I pull the block by x down, do you think these springs will compress by x? Right. So that much we know it will not be x. How much, that is a different story to figure out. Think. M by k sine. K sin. Sin or sine or what is that exactly? Chalo, let me help you with something. See, suppose we have a block here M and we have a spring at an angle. Let's say this is theta. Now, if you push this by x to the right side, now you tell me, if I push this by x in this direction, how much will you think it will go? This will go x cos theta. Do you agree? The component of x along the spring. Again, we are talking about small angles, okay? This is for small angles. Great. That means the spring will get compressed by x cos theta. So if you look at the forces, this force will be kx cos theta. This is theta. So this can be written as, so the horizontal force will be kx cos theta ka cos theta. So kx cos square theta is equal to acceleration. So this guy is looking like kx cos square theta is equal to minus m into a. So when you look at this, what are you getting the feeling? So this spring at an angle is behaving like a block M connected to a spring in the horizontal direction whose spring constant is k cos square theta. Does that make sense? So you can replace that spring at an angle with a horizontal spring, which is k cos square theta. Why are you getting cos square? Two reasons. One, when you push it, elongation is x cos theta. Then force ka one more component is one more cos theta. Cos theta ka cos theta. Are you getting it? So there. So you can replace this. The springs at an angle with k cos square theta. Now coming back to our question. This was theta. This was theta. I can replace this with a block M. This was k. This was k cos square theta, k cos square theta. We have done this question last time. All three are in parallel. So k equivalent will be k plus 2k cos square theta. Time period is 2 pi root over m by k equivalent. I can put any angle I want, 60, 30, 45. The numbers will take care of themselves. We did this problem, remember? This was this question, na? Doesn't this how it looks like? If you just make it vertical, यही दिखेगा. Any doubts on this? It's a good one, at an angle one, saves your time. Meaning you would have done the same thing. You would have written, when you pull it by x, this is the force and all. You made it more generalized. So if you have a spring at an angle, you can just make it as k cos square theta. So k equivalent is k cos square theta. What is theta here? Theta is angle between displacement and the spring. Next one. Clear na? Vignajit, Surya, Palak, clear with this? Adi, clear. Next one. We got a block of mass M. We have K, and this is a massless span. This side is H. Gravity is there. Release from rest. What will happen? The block will fall, the spring will compress, then the spring will push, the block will fly. So this block will just keep on going up and down. Find time period. It's a good one. It looks innocent. It's a serial killer. this, so I would ask you advance में integer or maybe matrix, more than one choice question. Try. I'll give 3 minutes. And do you remember seeing this anywhere else? Anyone remember seeing this problem? Where? Remember this? Question 27, work per energy. Find the maximum compression in the spring. This is what I keep saying. Physics may, right? You won't keep seeing new things. There'll be like 60, 70% something old. You just keep adding more and more. That's what makes physics different from other subjects. Every subject is unique. Physics is this. That's what I'm telling you. If I have to revise physics, I can just take 100 questions and revise the full portion. You can't do that in Max and Chem. Let's get this. Think about it. Then I'll show you something and then I'll give you a few more minutes. I'll tell you what people do see. Listen to this. What I'm saying, listen and tell me what is the issue here. So when it is freely falling here, this will take root over 2h by g. Freely falling, right? Kinematics. Then once it hits the spring here, from here to here, it will go to the extreme position. So this time period is t by 4. So while going back again, this is t by 4. While going up, this is also root 2h by g. So the answer must be 2 times root over 2h by g plus t by 4, where t is nothing but 2 pi root over m by k. What do you guys think? Don't use your feelings. Someone is like, because sir told this thing, it must not be true. Hey, feelings nahi hai. Don't guess what I'm trying to say. If you want to say this is wrong, tell me what is wrong in this. इतना तो idea आ गया ना ये wrong है. So what is wrong in this? Ahana told. Ahana has right answer. Nikhil, I'm not clear what you wrote. This will be one of the option in the exam. 90% people will mark this and come. Gravity? What? Gravity is not, gravity to hey na re. Ahana, continue solving na. You got the idea. You solve, you figure out the actual one then. Others, what do you guys think? I'll give another 30 seconds. It doesn't go back to the same. क्यों same height नहीं जाएगा God? Is there any loss of energy anywhere here? Tell me who is losing energy here. Then what's wrong with this? This is definitely wrong. What's wrong with this? So let it lose contact with the spring. क्या problem है? Acceleration is changing. अरे God, do you mean in SHM acceleration constant है क्या देवांश? Then the block would go below the equilibrium position, so it won't be. I think you understood, Nikhil, but I think you're not getting the right words to say that, but I think you got it. Listen, tell you, someone is typing. Falak, you want to say something? Bolo, bolo. You can say, I don't mind. You can say something. Listen, the mistake is this. What is mean position? Mean position is a point where net force is 0. Agreed? The mistake we did here is the natural length is not the mean position. At the natural length, what is the force? Mg. Spring force is 0. Force is not 0. So the spring will compress further. Yahi kahi pe, at this position is the mean position. That means if you actually look at this time, this is root 2h by g, agreed. This will be some time t2 and this will be t by 4. So बीच में एक t2 आएगा. Natural length to mean position, that time we need to calculate. Are you getting it? That is a mistake in this. So let me show you the steps. If you got this, continue solving. That's what I said. That this thing, right, is gives you an illusion like, this much only. But there is a trap there. So you have to draw the diagram carefully. Look at the diagram. This is M. This was your pan. So this will fall from here to here. Let this be T1, which is root over 2h by g. This is from kinematics. Then the block will hit here, M. Remember, this thing is still natural length. Then the block will compress further. At this position, this will be kx and this will be mg. This distance will be mg by k. This is your mean position. Matlab, from here to here, there will be some time t2, which we don't know. And at this position, the block will also have maximum speed because it is a mean position. So the one common mistake, right? People think you get maximum speed at natural length. As long as mg is greater than kx, the block will continue to accelerate, isn't it? After this point, now when the block goes further down, now you will reach an extreme position. You will come to rest. This is extreme. This guy will be the amplitude A. And this time will be T3, which is T by 4. So the total time period will be 2 times root over 2h by g plus T2 plus T by 4, where T is nothing but 2 pi root over m by k. So far, everything great. So if I know T2, my job is done. How to find T2? But Ahana, in that, what is A? A is not given, na? A is something which you assumed. What is A? Try. I'll give you 2 minutes now. How do you find T2? But now you got the story, everyone. There are 3 parts to the problem. Free fall, then falling from the mean position, the natural length to mean position. So natural length is not the mean position. That was a catch. How do you find T2? So let me help you out. Can you find the amplitude? Because see, if I know the amplitude, I can do this thing. I know x is equal to a sine omega t. So if I substitute x is equal to mg by k, then I will get the time interval from natural length to mean position t2. So I will get t2 is equal to 1 by omega sine inverse mg by ak. There. So if I can find amplitude, my job is done. So you need amplitude. isn't it? X is equal to a sine omega t. X is the distance traveled from mean position to natural length, and the time is t2. So if I can find amplitude, my job's done. Numbers are given, you could have solved. So how will you find amplitude? Think I'll give you a minute for that. It's near. How did you get such a good one? See, the second part comes from conservation of energy. This is my state 1. This is my state 2. So can I say like this? Loss in gravitational potential energy. Because here also you're at rest, na? Is equal to gain in spring energy. So all the height you lost went into the spring. So how much height did you lose? This height, which is h, this height mg by k, and this height amplitude, na? That is the total height you lost. So that would be mg h plus mg by k plus amplitude is equal to half kx square. Remember, x is measured from natural length. So the total compression in the spring is mg by k plus a ka square. So you get a quadratic, you have to solve, you'll get a value from here. Is that clear, everyone? So you get the amplitude from conservation of energy. Understood why I said it is a assassin, silent killer? Initially, when I gave the problem, it looked so innocent, na? And see how many things are there. We have kinematics, we have SHM, we have conservation of energy. And this was the problem which we did in work power energy. If you see, this was a question, find maximum compression. Here also I wrote the same story. Look at the diagram, the same diagram. I couldn't ask you time then because you don't know SHM. And this was the amplitude we calculated. Meaning there I gave you the value for h, 2 mg by k. This was the amplitude there. Yeah, this was something like that. Clear with this? Any doubts on the steps? Next one. We have a rhombus. Lentil, 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 lentil. Connected by a spring in the middle. These are movable hinges. And here we attached a block M. Gravity is there. So we have a rhombus made of 4 light rods. So rods are massless. Made of light rods of length L. And you have connected a spring between them as shown. So how will this guy move? Look at this picture. So if I pull this block down by X, you're getting the spring will get compressed, isn't it? The spring gets compressed this way. Able to visualize the picture? So this will go up and down and the rhombus will compress and expand like this. Everyone is getting the shape, how it is moving. Find time period for small oscillations. This angle is theta, this angle is theta. So half angles are theta there. Again, small oscillations because I don't want angle to change. If block is pulled down by X and released, find time period. Why isn't AMG vacuum? Vihan, that is clear now, what you wrote?
No, so like this will be built down.
Figure it out then. Why is that not right, God? How the hell did you even get that statement, what you wrote? See, just don't write any weird statement now. You have to have a proof, right? When I ask you. How did you get
Like
that? Logic bata.
so it's at h its velocity was 0. So we
Uh-huh.
put the mean position was when it first hit the pan and then depressed by further mg by k and then it reached mean position.
What you're talking?
So first it falls down, hits the pan, and then it goes down further by mg by k.
But initially there is no spring. So you're telling me after the mean position, spring will get disconnected, it will fly in there.
No, so but it traveled that much distance, so I thought that that would be the amplitude.
Think, na, you didn't think properly then.
Uh,
Think about it and you tell me. Realize it's a blunder. It's not so clear, na? What you got is wrong. Now figure out why it is wrong. Let's get this first. Think about that later. Oh, just God, I can't see you. Your camera is completely blank. Arnav, your camera is also completely blank. So please do something about that, Arnav. This is already the third class. Your cam is still not working. Hmm. How to do this? I'll give you a hint. See. Let's start with this. If I pull this by X, can you tell me how much will the spring compress? Do you think spring will compress X? No, na. How much is that? Start the question from there. If I pull the block down by X, how much will the spring compress? I'll give you a minute. Figure out that part first. क्या हो गया वो just forgot there's a class. You got disconnected again. Surya, you trying? Try. The way you guys sometimes look at the camera, na, I get a feeling like you just kept your eyes open and you slept. I used to do that in my social studies class in 10th standard. Keep your eyes open and just keep staring at the board. root over x square minus xl sine theta. And okay, let's see. Let's see the first part. You got cot theta over right, Ansh, but 2 extra here. Look at this thing. So this is theta, this is theta. So this length will be, this is L, na? So this is L cos theta. This is L cos theta. L sine theta, L sine theta. So if I take this as x coordinate, I can take x and y, anything, it doesn't matter. If I take this as y, so from here you can clearly see x is equal to 2L cos theta. Differentiate on both sides. Now understand one thing here. I'm not interested in x and y. I'm interested in change in y when there's a change in x. You're getting it? When x changes, how much will y change? I'm not interested how much is x and y relation. So if I differentiate this, I'll get dx is equal to minus 2L sine theta d theta. Similarly, y is equal to 2L sine theta. If you differentiate this, we'll get dy is equal to 2L cos theta d theta. Now, if you divide them, I will get dy by dx is equal to minus cot theta. So I will get dy is equal to minus dx cot theta. Meaning what? If I pull the block by dx downward, then my spring will compress by dy. Isn't that the meaning of it? And the negative indicates what? If x increases, y will decrease. Anansh, meaning two sides will compress, but you have it, two sides will also elongate, na? Getting it? So this means when block moves by dx, spring compresses by dy. And negative indicates compression. There. Now what? So if you pull the block by x down, the spring will compress by x cot theta. Now how do we solve? Try. I'll give you a minute more. So if I pull this point by x down, this will compress by x cot theta. This is the compression in the spring. Understand one thing. What we are interested is not the spring force. We are interested in change in spring force, isn't it? We are drawing FPD of change in forces. Because the initial compression and the initial tension, these all will cancel out. So now if you take this rod here, if this is tension, this is tension, the spring will push like this, which is kx cot theta. This is theta, so this is 90 minus theta, 90 minus theta. So from here we'll get 2t cos 90 minus theta is equal to kx cot theta. Similarly, here this will be tension, this will be tension, this will be theta and theta, and this is the block M. We will not write mg because M didn't change. So this T here is the change in tension. This will be 2T cos theta is equal to minus mass into acceleration. And from here we get 2T is equal to kx cot theta by sine theta. Substitute here. We get kx cot square theta is equal to minus ma. A is equal to minus cot square theta by m into x. Now SHM will come and hijack the problem. That's your omega square, and therefore your time period t will be 2 pi root over m by k cot square theta. You can make it also tan square. Check. Clear, everyone? That's the main thing there. So when you pull it, the spring will compress like that. It's a good one. Next one. Next one. Any doubts on the steps? The compression part of this thing. Since the rods are light, tension has to be same everywhere. There's a catch about the rods being light. Let's do some easy one. Suppose we have a platform like this. This is mass M. This is a massless man. Find maximum amplitude so that the block does not lose contact. This would be a simple CET or main cell question. But Purush, X is very small, right? End of the day, you have to do binomial approximation again. Then you have to take theta also in terms of X. Isn't it? See, when I do that, when can you differentiate when X is very, very small, isn't it? If you do that, you should get the same thing. Try karke dekho, you should get the same. Find max amplitude. That means if this block starts oscillating, if you give too much amplitude, what will happen? There is a possibility the block will fly from the pan like this, isn't it? I don't want that to happen. So find the maximum amplitude so that block does not lose contact. This is a straightforward main cell question. Get this. I'll give you a minute or two. Let's see. 2 mg by k, mg by k, that looks right. So let the displacement be x. So when the displacement is x, if you draw the FBD of the block, we have forces normal reaction, we have weight mg, and we have acceleration, which is minus omega square x. So we have n minus mg is equal to ma. N will be mg minus m omega square x. Since you don't want to lose contact, n must be greater than or equal to 0. Therefore, x must be less than or equal to g by omega square. Omega square is nothing but k by m. This is mg by k. There. So x ka value can't exceed this. Make sense? There's a much faster way to figure out this, Think about this. If there is no pan and all, and if there's nothing, if you leave the block, what is the acceleration of the block? G, right? Meaning no matter what you do, you can't fall faster than G. So can I argue with this statement? If the pan ka acceleration becomes greater than G, the block will lose contact. If the floor goes faster than G, shouldn't the block lose contact? Because block can't go faster than G. And what is the acceleration of the block? Omega square x must be greater than or equal to 0. So x will be greater than or equal to G by omega square. If this happens, block will lose contact. Make sense? So you could have argued like that and got the answer in one step, but okay. This thing you can find normal reaction as function of x. Clear with this? This is a proper mains level question. They do ask out of 25 questions, there'll be like 12 to 15 of this level. Next one. Let's see slightly more complex. It would stop extending once it extends. Yeah, you can say that. Same thing, no? After that point, the block will lose contact. So next one. We got a block M, K, mean position. So this is oscillating with so block oscillates with amplitude A. Then what you did, you took another block of same mass, is attached to the block. But when did you stick it? There are two cases. Case one, at mean position, meaning when this block is oscillating at the mean position, when your speed is maximum, you took another block of mass m and then you suddenly stuck it. Basically, E is 0. Think of like this, you're going on your cycle and your friend comes and jumps on the back seat. What will happen to your speed? Won't it suddenly just drop? That's what it feels like. Case 2, at extreme position. So when the block is at the extreme position, when the velocity is 0, so the block has just come to rest. Then you took the block M and you stuck to this. Find the new time period and the new amplitude. I hope the scenario is clear, everyone. Try. Get the first one. I'll give you 2 minutes for case 1. Sharman, clear so far? Arush? Clear, na, Arush? Yeah. Ojas? Clear so far? Great. Right, Falak. Time period is the easiest one, isn't it? Time period doesn't care about the oscillation, amplitude, nothing. It is 2 pi root over mass by k. Mass has become 2m. Done. So time period is the easiest one. Right, Arush. Get the first one. Na? You got the case 2 first. Let's see. The first case, the amplitude is a by root 2. So at the mean position, your speed is maximum, which is a omega. Omega is root over k by m. Since you're at the mean position, what is the net force? Since this is mean position, force is 0. So if force is 0, then linear momentum is conserved. You're getting it? At mean position, when the block suddenly gets stuck, the linear momentum is conserved. What about energy? E is 0, right? So it is getting stuck suddenly. Na? So there is a slipping, isn't it? If there is a relative velocity between two blocks, and if you make them stick, what will happen? They will slip for some time and then get stuck, isn't it? But energy is not conserved. You lose some energy. So energy is not conserved before and after sticking. So this thing is like a perfectly inelastic collision. That means the moment this block gets stuck, M and M. Remember, this is still the mean position. And your speed has become Vmax by 2, which is A omega by 2. Isn't this the new maximum speed? Because you're still at the mean position, this is your new maximum speed. And what is your omega nu? Omega nu is root over k by 2m. Therefore, the new speed V nu max will be the new amplitude into omega nu. This guy is A omega, this guy is A nu. This is omega by root 2. Therefore, the new amplitude is A by root 2. This is one way to figure it out. Makes sense, everyone. And the new time period will be 2 pi root over 2m by k. There is another way to do this. After the sticking is over, energy is conserved. Agreed? After the block gets stuck, then energy is conserved. So that is another way to do this alternatively. Because only during the process of sticking you lose energy. After blocks are stuck, energy is conserved. That means I can do this thing. The kinetic energy of 2m, the speed has become v by 2 whole square is equal to the spring energy of k, the new amplitude square. Make sense? So once the block is stuck, you actually lose half of the energy. So with that remaining half of the energy, the spring will get elongated. Is that making sense? Since the energy has become half and half kx is square, so x will be 1 by root 2 times. So you can just orally also say that thing. Is that logic making sense? If I give energy E to a spring, kitna elongate hoga? E is equal to half kx square. If I give half the energy, then how much will it elongate? E by 2 is half kx square. So x has become 1 by root 2 times, isn't it? So in the process of sticking the block, you lose half the energy. Because both the masses are same, velocity becomes half. Half 2mv by 2 whole square. So any doubts on this thing? Clear, na? So see, there are a few questions, right, where you need to solve. There's some other things, you can just see orally and figure it out. You can do this thing, both the ways. So there are two ways you can solve. What about case 2? Case 2 is interesting. The block is already at extreme position. This is your mean. Your velocity is 0. So there is a spring force, kx is there. So F is not 0. So linear momentum is not conserved. So this thing can be asked in more than one choice as statement questions. In which case momentum is conserved, in which case energy is conserved. But energy is conserved. Why? There's no relative velocity. There's no slipping. The block is coming with 0 speed. This guy is also at 0 speed. So think of like this. If you are going on a cycle and your friend comes and jumps on the back seat, don't you have to cycle harder? You lose energy, right? Suppose you're standing there with a cycle and doing nothing, you're at rest. The friend comes and jumps on the cycle. Do you lose any energy? You don't lose any energy because you're at rest, that guy is at rest, nothing happens. So that is the thing here. Since V relative is 0. But fir bhi, if you think there will be some change, then let's calculate and see. So this was the extreme position. So block M, velocity is 0. This was your mean. This was the amplitude. So let's say for some reason you think amplitude will change. So let the block come this side. Let this distance be a dash. Since this is also extreme, V is 0. So conserve energy. Half k a square is equal to half k a dash square. So a dash is equal to a. Yeah, you can kick your friend out, but in the problem, we don't do that thing. Let's get this. All clear? Let's see one more. Any doubts on this? It's a decent one. Just to give an idea, suppose if the block is stuck at x is equal to a by 2, then what would you have done? Just tell me the steps. Think a minute. If the block is stuck at x is equal to a by 2, just think what will be the steps. How will you proceed with that? And then I'll tell you what to do. Is spring force impulsive or non-impulsive? Is spring force impulsive or non-impulsive? Non-impulsive, right? Kx, the value doesn't go to, what is impulsive? It goes to a huge value in a short time. Spring value doesn't do that. So even though the force is not zero, because the time interval dt is very, very small, we can, assume, because there's a non-impulsive force, we can conserve momentum just before and just after collision. You're getting this? If you remember, we have done this kind of questions in momentum also. For example, see, if a ball m is coming down with you, if a ball 2m is going up with 2u, gravity is there. So technically speaking, you can't conserve linear momentum because there's an external force. But then we argue, since the time of collision is so small, right, and mg is a non-impulsive force, means it's a very small force compared to the forces between the collision, we can ignore mg for just before and just after collision. Are you getting that argument? You can't ignore it throughout. So just before, just after, you can ignore and conserve momentum. So same way, so at a by 2, what will be the velocity? At a by 2, the velocity will be v is equal to omega root over a square minus x square. So just after sticking, the velocity becomes half. Clear with that? And then you can conserve energy after sticking and then solve the problem. So momentum can still be conserved approximately just before and just after sticking. Is that clear, everyone? So that is how you do in case if you're getting stuck in somewhere in the middle. So every time they won't ask you mean and extreme. Those are some standard cases. I can ask you even in the middle also. Let's see one more. This is a smooth massless pulley. Find the time period in both the cases. That is also smooth massless pulley. First was easy. Second is a good one. Remember the process. Choose your system, logarithmic system, displaced by x, and then see what is the elongation in the spring. Then apply f is equal to ma, and then compare with a is equal to minus omega square x. The story is still the same. A is same as hanging. Yeah, A is same as hanging from the sun. कुछ difference नहीं है. You just twisted the rope. So look at the first one. If I pull the block by x down, the spring will go up by x. So this will be tension and this will be kx. Tension is equal to kx. Remember, all these are change in forces. This is block and this will be same thing, the same force here, tension T. I wrote reverse actually. Wait. This is tension and this is kx. This is change in spring force, change in tension. And acceleration. So T is equal to minus ma. Kx is equal to minus ma. A is equal to minus k by ma. So x. Standard stuff. 2 pi root over m by k. I will just use small t. I used already capital T for tension. What about this guy? Right, Ahna. If I pull this by x, do you think spring will stretch by x? See, I don't know, but I'm pretty sure x तो नहीं है. That is the first thing. So then how do we calculate this? So let this spring go down by some y. There I'm drawing a picture here. So let's say from here to here. So that means this is going y down. This is going y down. So whenever the block goes down by x, how much will the pulley move? Y. And how much will that string should be? 2y is equal to x. Agreed? So all the string that is missing here and here must have gone into the block, isn't it? Any doubts on this part? This comes from constraints, everyone. If the pulley moves by y down, it will release 2y string. And all that string must go somewhere. Who will take it? The block, because the left side is fixed to the wall. Is that making sense? Now draw the FPD of the pulley. What are the forces? K into y, tension, tension. So we get 2T is equal to Ky. Then for the block, the forces are tension, acceleration, T is equal to minus ma. This will be K into y is minus ma, but be careful, you want A in terms of x. When you pull x, what is the acceleration? I don't want y. T is ky by 2. But what is y? Minus k by 4m into x. Therefore, the time period will be 2 pi root over 4m by k. So two things happened there. When you pull the block by x down, the spring elongated only x by 2. And because there are two strings, the tension became again half. So half into half, it became 2 times. So you got a 4 there. Is this making sense, everyone? So one spring, there is only one spring, so फिर भी it is ठीक है. If you have 3 to 4 springs, it becomes a mess. So we will see how to do that. Also, if you have more than one spring, it's not that easy like this. But let's see after that in the break. Take a break. Come back by 7 to. We'll continue from here. Any doubts so far? Okay, come back in 10 minutes.
Sir, on the 62nd page,
60-second. Huh.
no, sir, I understood. Sorry.
Yeah, come on, everyone. Now there is a much faster way of doing this. Equivalent spring. So this actually comes from work power energy. Think of like this. Let's say if there are some n number of springs, okay, there are a lot of springs. And I want to replace all these springs with one spring so that I can solve the problem. Now we know the spring energy, spring potential energy is given by half kx square. Can I write this thing as kx whole square by 2k? And what is k into x? K into x is nothing but tension by 2k, where T is the tension in the spring. So if there are n springs, then the tension in the first spring by K1, tension in the second spring by K2, so on till tension in the nth spring by Kn must be equal to the total energy in one single spring, which is T square by K equivalent. The total energy stored in that equivalent spring must be equal to the energy stored in all the springs. Does that sentence make sense? So this actually comes from conservation of energy, right? The proof is not really that important. So this is the result that you'll get. T square by K equivalent T1 square by K1, T2 square by K2. If you remember in NLM, we did something like this. That was even more complex. T square by Kn, where Tn is the tension in the nth spring. And this T here is the total tension on the block. So using this, I can find K equivalent easily. The only problem with this is valid only when you have a single block. You should have only one block, but you can have 1,000 springs. There is no problem. Valid for one block and smooth and massless pulleys. So let me take an example. So the previous problem which we did, so this is how you start. Let the tension be T anywhere. It doesn't matter. Take T anywhere you want. I will take T here. If this is T, this is also T. That means this tension will be 2T. Now look at the formula. Tension on the block is T square by K equivalent. Tension in the spring is 2T whole square by K. Therefore, we get K equivalent is equal to K by 4. Therefore, time period will be 2 pi root over M by K by 4. 2 pi root over 4M by K. Same answer. Now this thing, right, will shine when you have a lot of springs. If you have 3-4 springs, trying to do the previous way becomes really difficult. But this will give you answers pretty fast. Quite a useful concept. But you can use this only when there is one block. Clear, everyone? You can note down that formula in the red box. Let's see a few problems based on this. Tension on the block is T. I use T only, na? 2T is the tension on the spring record. The left hand side T square by K equivalent, right? Clear? Got the example? Let's see a few questions on this. I think then you'll get used to the formula better. Suppose if I have a spring here, so 2 springs are there and there's a block there. Now, if you try to solve this will be a little complex normally, but this method will give you the answer pretty fast. Find the time period. Find the time period. Remember, you can start T with anywhere. You can say this is the tension T, and then K1, K2 diya hai na. Everything is K1, K2. I want you to know which one is 2T, which one is T properly. That's why I keep it in K1, K2, K3. This method will really shine when you have a lot of springs. विहान क्या आया गॉड तुझे हाँ? तो K1 K2 ही निकाल दिया ऑप्शन से.
It got sent before I wanted to type.
ठीक है, solve. Let's see. Start with the tension T anywhere. I will start with this is T. If this is T, K2 may also tension is T, and this guy will be 2T. So look at the formula T square. That is the tension in the spring by K equivalent. So in the spring K1, it will be 2T square by K1. So T is the tension in the spring by the spring constant, and this is T square by K2. So we have 1 by K equivalent. Four by K1 plus 1 by K2. Time period is 2 pi root over M by K equivalent. Substitute and you're done. What about this guy? You can start with tension T anywhere. I will again take T here. If this is T, this will be T by 2. This will be T by 2. If this is T by 2, this will be T by 4, and this will be T by 4. You could have taken tension anywhere. It won't matter because it's a ratio. No? It will cancel out. If this is T by 2, this is also T by 2. This is also T by 2. Then this guy will be 3T by 2. There are 3 strings there. Please check the tensions here. Now, if you write, we have T square by K equivalent. So K1 में tension is T by 4 का square by K1 T by 2 का square K2 plus 3T by 2 square by K3. Not a great thing, but 1 by 16 K1, 1 by 4 K2, 9 by 4 K3. Substitute there, you'll get the answer. Yeah. Remember this thing, there are 3 strings here. If you look at this pulley here, this is that K3. You have T by 2, you have T by 2, we have T by 2. So the tension there is 3T by 2. Clear, everyone? Now, if you try to do this normally, it's a mess. You will say, let the block be pulled down by X, then X1 will stretch by X1, X2 will stretch X2, X3 will be X3, and then you have to find relation between X1, X2, X3. You have to use constraints, force equations. You will get it. It will be quite long. This will save you time. Any doubts on this? Let's take one more like this. If you got that, then I think you will got this. Clear? We have a block like this. K1, K2, K3. Find the time period. You can start tension T anywhere. Since it's a ratio, that will anyway get cancelled out. Let's see. Let the tension be T. If that is T, 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 so this guy is 2T. This is also T, so this is 2T. This is T, this is T, this is T. So this guy will be 3T and this guy will be 3T. Perfect. So now when you write a T square by K equivalent, what is this T exactly? There is a total tension, right? So that will be T plus 2T plus 3T ka square by K equivalent. You're getting it? The total tension acting on the block is connected to string at 3 different points. So the block will think there's a 60 tension, isn't it? So that is a catch in this thing. So if your same block is connected at multiple points, you have to add all the tensions. Then, so this was the total tension on the block. The previous examples I gave, the block is connected only one string. And this guy will be T square by K1. 2t square by k2, 3t square by k3. So this guy will be 36 by k equivalent. 1 by k1, 4 by k2 plus 9 by k3. Substitute at the time period. That's what is this question is different from others. You are connecting the same block. There is still one block only, but it is connected multiple strings. Clear, everyone? So this result or whatever we have is pretty useful. When you have one block, you can use it for any variation. But the moment you bring two blocks, then you're gone. You have to go back to the regular one. Assume the block is pulled by X, find force, time period, all that stuff. Everyone clear with this? So if you see, these are some spring and block-based problems. Now, like I said, in SHM, it is not always spring and block. You can have other cases also. Let's see the other ones also. Turning the page. Any doubt so far? Nikhil, clear, na? Surya, Daksha, clear? Purvaja, Pratik, Chainil, Ishana, clear? Palak, Ahana, Abhinav. Next one. Adi, clear, na? 28. We have a container filled with liquid. Here, this base area is, let's say, 3A. We kept a block here, area A, density rho B, liquid density rho L. Rho liquid is greater than rho B, it is floating. Find time period for small oscillations. We have done this as an example, if you remember. You know the process. Choose your system, displace it by X, find the restoring force equal to MA, and SHM will come. Try. I'll give 2 minutes. What is the catch? So that is the thing, na? Figure it out. What I gave you the example in display, कुछ तो different है. In the example, the liquid was big. Side B ले लेना. That was a concern. Let it be a cube of side L. So area will be L square, but ठीक है. What was the catch? Let me ask you this question. If I push the block by X downward, right? What is the extra Bayes force? How much extra depth the block will go inside? Look at that statement. If I push the block by X downward, how much extra does the block go into the liquid? It looks like I gave you the answer, but that is not the thing. if I push the block inside by X, the water and the surrounding also will rise because the areas are comparable. पहले जो example दिया था, it was like a big lake, so we neglected the height raised by the water level. In this problem, when I pushed the block down, we neglected the height raised by the water level. Look at here what happens. See, I'll do with variables. Let's say this area is A2. This area is A1. So now, if you push this by X inside, two things will happen. So from this level, right, this block will go, right, X inside. But because you pushed it down, the liquid will get displaced and you get extra depth here. That will be another Y. This is the liquid rises up. Is that making sense? You can try this. Take your bucket of water in your washroom. If you take that mug and put it in the reverse, won't the water level rise up? So how much is this then? Now, if you look at the top view, you will notice this volume is conserved. Whatever the liquid is being displaced. So if you look at the top view, it looks like this. So this was A1 and the surrounding area was A2. So volume displaced by the block is equal to volume raised by the liquid inside. Volume displaced by the block is equal to the the rise in volume. Or you can say rise in height of liquid. Not even the right words, but okay. So how much liquid did you displace? A1 into X. How much will the liquid rise? A2 minus A1 into Y. Do you agree? Because when you push the block, ये space नहीं होगा ना. You're getting all this liquid from here must have gone to this thing. You will only surround the surrounding liquid, isn't it? Is that making sense? The liquid will flow only in this space, Nare. You can't take A1 area again. Does that make sense? Everyone is getting that argument? So you got Y ka value. So now you tell me, what is the buoyant force then? So when you push the block by X inside, so you pushed the block by X inside, but the liquid went up by Y. So if the A2 is infinity, we can ignore this. If A2 is very large, then Y tends to 0. So that is the reason we ignored in the example problem. If I didn't mention anything about the base area, you can ignore this. So we have the extra buoyant force delta FB. So delta FB is equal to minus mass into acceleration. So this will be rho liquid G. Volume will be L square into X plus Y is equal to minus rho body L cube into acceleration. So we get acceleration will be minus rho liquid G by rho BL. This guy will be 1 plus A1 by A2 minus A1 into X. That would be how much? A2 by A2 minus A1. And then, you know, our SHM will come and say this is omega square. Time period is 2 pi by omega. Is the thing clear, everyone? That's the difference. If the block was pushed in a lake or something, lake area is very big, you can ignore this. But if the base area is given, it is comparable. So in our question, A1 is A and A2 is 3A. You can substitute there and you can solve. Any doubts on this? Clear? So that is the difference between the example problem and this. Next one. So when I gave the base area, that should have been little suspicious. Like, so if you push the block by x down, extra bind force won't be x, it'll be x plus y. Next one. We have a U-shaped tube, but the sides are bent like this. Theta, theta. You filled it with liquid till here. This is length. This is also length, and this is also length. So you pushed one side by x and released it. So you pushed one side by x and released it. So what will happen? It will oscillate, na? The liquid will oscillate left and right. Find the time period for oscillations. The liquid is displaced by small x. On one side and released. Find time period. If I make theta is equal to 90, that would be a U shape. That's a standard question. How do we do this? Let's see. So what is the catch here? If you push one side by x, what do you think will happen? Let's say if you push this side by x. So this is the new liquid level. But because you pushed this side by x, the liquid will also rise here by x, like this. Agreed? Isn't it? So what is the restoring force here? So we have two restoring forces here. So this entire section here, because of this thing, the liquid is moving, isn't it? So this thing will have two components. So this component will be some mg sine theta, and this component will be mg. Do you agree, everyone? That will be the restoring force. What is mg sine theta? Rho area x g sine theta. This will be rho a x g. So the restoring force, because see, till here the height of the liquid, right? This liquid will remain in equilibrium, but the reason it is moving is because of this extra piece. So when you push the liquid by x, the other side will go x plus x at an angle. That is conservation of volume. So F restoring will be rho a x g 1 plus sine theta. This must be equal to mass into acceleration. Which mass? Now this liquid is pushing this entire liquid here. So you should take the total mass. So rho a x g 1 plus sine theta is equal to mass will be rho area, the total length is 3L into acceleration. Rho area will cancel, rho area will cancel. We have acceleration is equal to minus g by 3L 1 plus sine theta into x. As usual, SHM will come and say that is omega square. So time period will be 2 pi root over 3L by g into 1 plus sine theta. If I put theta is equal to 90, that becomes my standard question. Is that making sense? It behaves like there's an incline and there's a vertical thing, isn't it? You know, you can make it even more fun. What if this side angle is theta 1 and this side angle is theta 2? Then what do you think we will do? If you put theta 1 and theta 2, then what will you do? You'll get two different time periods, no? So you will get time period like T1 will be 2 pi root over 3L by g into 1 plus sine theta 1. When you're on the left hand side, you'll get time period 2t will be 2 pi root over 3L by g into 1 plus sine theta 2. Total time will be half of each, isn't it? When you're on the right hand side, that will act. When you're on the left hand side, this will act. So you will get half of each. That's not tough. Matlab, theta 1, theta 2 will look scary, but it is doable. Clear with this? So these are not tough questions, but they're a little different. Like you should know, oh, this is what is happening. That way they're a little different. Next one. We have an insulated container. We have a piston of mass m, smooth and insulated. Movable. Area is A. Left hand side, the pressure is P naught, V naught, temperature is T naught, P naught, V naught, temperature is T naught. Here we have helium gas, here we have hydrogen gas. Now initially both the things, right? So now we have both the sides, the pressure is same. Pressure is same, so the piston will be at rest. Now tell me what happens if I push the piston towards the right. If you push it slightly towards right, what will happen? This side pressure will increase, so it will push the piston back. If it goes to the left, then this side pressure will increase, this will push to the right. So piston will start oscillating. Find the time period for small oscillations. Thermodynamics and SHM, everyone. How do we proceed? What did I tell you? You can bring any chapter into this. One of my favorite chapter. The seniors so literally harass them with SHM everywhere. I give a question and I'll say SHM and they're like, what the hell? Why did it come here? Let me ask you something. When you push this piston to the right side, what kind of process is the gas undergoing? Answer me that. When you push the piston, what kind of process is the gas undergoing? Arush, what process? Right, Ahna. Others. Arush, adjust your camera a bit, right? Can't see you. Isothermal. Why it is iso, right? God. Think about it. Here, the piston is insulated. Container is insulated, meaning heat can't escape anywhere, isn't it? Adiabatic process, isn't it? So when you push the piston towards right side, the right side gas is undergoing adiabatic compression, whereas the left side gas is undergoing adiabatic expansion. For an adiabatic process, PV per gamma is constant. Now what? Let me help you. See. So this was the mean position. Let's say this thing is pushed towards right. Let the displacement be x. So let this side the pressure become P naught plus dP1. Here the pressure becomes P naught plus dP2. I know left side the pressure should decrease. Science will take care of it. dP is the change that can be positive or negative. Now I know for an adiabatic process, PV per, so this thing is an adiabatic compression. This guy will undergo adiabatic expansion. So end of the day, both are adiabatic processes. We know PV per gamma is constant. And we know gamma is 1 plus 2 by F degrees of freedom. This side is helium and this side is hydrogen. Oh, did I write reverse? Right only. So I can find gamma, differentiate this. So I will get dP V power gamma plus P into gamma V power gamma minus 1 dV is equal to 0. From here I get dP is equal to minus gamma P by V into dV. This we have done in bulk modulus if you remember. Clear? Now dP1 will be minus gamma helium. I'll just write gamma 1 P naught by V naught. What happened to the volume? Minus A into X, right? Because right side volume decreased. This is what I said. Science will take care of it. So you got positive. P naught AX by V naught. Similarly, dP2 will be minus gamma 2, which is P naught V naught. Here the volume increase, so plus AX. There, dP2 is negative. So mathematically assume it is always positive. Let science take care of it. There. Now draw the FBD of the piston. So this side the force is P naught plus dP1. This side the force is P naught plus dP2. Let this acceleration be A. P naught will cancel into area. Then we end up with dP2 area minus dP1 area is equal to mass into acceleration. But what is dP2 minus dP1? This guy will be take out gamma 1 plus gamma 2 P naught by V naught A square into x is equal to ma. So we get acceleration is equal to minus gamma 1 plus gamma 2 P naught A square by m into V naught into x. As usual, SHM will come and say this is omega square. And then we get the time period from there. So time period will be 2 pi root over mv naught by gamma 1 plus gamma 2 P naught A square. So gamma 1 is helium 1 plus 2 by 3. So that is 5 by 3. And gamma 2 is 1 plus 2 by 5. That is 7 by 5. Substitute, you get the answer. So this entire thing was thermodynamics. You can do this only for small x, or else you can't find dP, and you can differentiate only when p is very small. Is this making sense, everyone? Now here, if you want to do something more, I can put one spring also. Plus kx aa jayega extra. So it's not really that different. Please have a look at the steps. This is how they'll frame questions in advance. Means we'll never see something like this. And don't think like, oh sir, how will we get an idea like this during the exam? I completely agree, but now you know. So next time you see something similar like this is what I keep telling you. They won't ask you the same question. Exam, they might do something like this. They might put a spring here and they might put a spring here, and they'll call it K2 and K1 extra. So whatever you did, uska plus extra K1 plus K2x aayega. That's it. So at least now you know how to approach a problem like this. Clear with this? Any doubts on the process? Next one. Should definitely try this on your own. We have a table here with a small hole. Here we have a body M, which is going in a circle. So on the other side, you have a capital M like this. Gravity is there. You're getting it? So this is a smooth table. So initially this block is at rest. So basically when this guy is rotating, this centrifugal force is balancing this weight, isn't it? So this guy is traveling with some speed. We don't know how much, but it is going in a circle. A ball M is rotating in a circle of radius r. So this guy ka radius is r. The other end is connected to a block through a hole. So the big block is at rest. Now what you did, you caught that big block and you pulled it by a little down. If block is slightly pulled down and released, Something happens and this thing starts oscillating. Find time period for small oscillations. Let the radius be smaller. First, you need to understand why it will oscillate. Figure out that part. That's what I keep saying. Don't directly jump into the question. Take a minute, think why it is oscillating, why it is moving, what is that, what is this? Ask yourself some questions. Right, Vihan. Solve. Seen somewhere before? Or thought about it right now? Seen somewhere before? No, you thought about it. Acha, good then. Radius decrease hoga. So that is obvious. Now, if you pull the block down, the radius decrease hoga. What did you find out from there exactly? How do we approach this? Think. Forget about solving the question. Did you guys figure out why the hell this thing is oscillating? If I pull this down, why the hell it is going up again? See, when you are oscillating means what? If I pull it down, I want the block to go up. Someone must be pulling up. So what changed in order for this to go up? Start from that thing. You need to get the reasoning first. Solving baad mein aayega. There's no point in just putting pen on the paper and just scribbling something when you don't understand why the hell it is going up. Did anyone figure out why it is going up? I'll give you a hint. Conservation of angular momentum. Conservation of angular momentum. So Karna Vihan, you already got it. You continue solving, you get the final answer. If you pull the block down, radius will decrease. If the radius decreases, then speed will increase. Because MVR is constant, isn't it? The torque about the hole is zero, so angular momentum is conserved. So speed will increase. What is centrifugal force? mv square by r. V increased, r decreased. Matlab kya hua? mv square by r increased. So the tension becomes greater than mg. So the block goes up. If the block goes up too much, then the radius will increase. Means speed will decrease, centrifugal force will decrease, mg will dominate, the block will come down. So this will just keep on oscillating front and back. So here it is a fight between centrifugal force and mg. Surya? Surya, are you there? Yeah, you look exhausted. I know, a lot of different chapters. How do we proceed with this? See. So this was the hole there. So if you look at the forces, this was tension, this was mg, this was tension, and let's say this guy is going in a circle. The centrifugal force will be m omega square r. So we get tension is equal to m omega square r is equal to mg. So from here I got omega. This was your initial angular velocity. Now, when you pull it, this radius becomes r minus x. Now, if you look at the forces, this will be tension. This guy will be the centrifugal force. Now will become, so this angular velocity becomes omega dash. This will become m omega dash square by r minus x. And this guy will be mg, right? And this will be acceleration a. I can use the net pulling force method. So what is the net force along the string? Mg is pulling down minus m omega dash square r minus x is the centrifugal force is equal to total mass into acceleration. Is that making sense, everyone? So this guy also will move. Is this equation clear? We are taking the net force along the string. So along the string, what are the forces? Mg is pulling down, centrifugal force is opposing you. The net force is total mass, that is m and small m, into acceleration. Is that equation clear? Next thing, torque about the hole is 0. Why? Tension is passing through the string. Therefore, I1 omega 1 is equal to I2 omega 2. L bar is constant. So the initial angular momentum will be m into r square omega is equal to, this is m, now distance has changed, r minus x whole square into omega dash. So from here I get omega dash is omega into r square by r minus x whole square. This is your new angular velocity. Any doubts on the steps, please ask me. Clear what we did? So basically when you pull the block, the radius decreased, speed increased, or omega increased, so the centrifugal force has increased. Now take this omega dash and substitute in this equation. So we will have mg minus m omega dash square r minus x is equal to m plus m into acceleration. This is mg minus m omega dash square will be omega square r square by r minus x r power 4 into r minus x. This will be mg minus m omega square r power 4 r minus x whole cube. Take out r common. Mg minus, and remember this, I already know what is omega square. I'll substitute that. Mg by mr. This will be r power 4. Take out r cube common. This will be 1 minus x by r. Small m will cancel. R power 4 also will cancel. You'll end up with mg minus mg. This thing will go up, so you'll get 1 minus x by 3 whole power minus 3. We can use binomial approximation. This will be mg minus mg. The binomial approximation is 1 plus 3x by r. I'm missing something. No, that looks fine. So mg will cancel. You will be stuck with 3 mg x by small r is equal to m plus m into acceleration. Hope everyone remembers the binomial approximation. 1 plus x whole power n can be approximated to 1 plus nx if x is much smaller than 1. You could have differentiated. You would have got the same thing. I just wanted to show you, nothing much. You could have differentiated. Matlab, see, the moment you say binomial approximation, matlab, you have differentiation also would have got the same thing. So we get acceleration is equal to minus 3 mg by r into m plus m into x. There, as usual, SSM will come. The time period will be 2 pi root over m plus m into r by 3 capital Mg. Check. Yeah, how will the motion be? The motion would look actually like this. So this was a circle, no? So this thing will actually kind of go like this. Very small oscillation. It's not a proper circle. So this guy is going up and down. It's wobbling up and down, and this guy is going like this. Able to visualize? So the radius of the circle will go from r minus x to r plus x. So there's a small vibrations there. Every time it comes inside, speed will increase. It'll be pulled outside. If every time you go outside, speed will decrease. It'll get pulled inside. So it won't be a proper circle, but this is how the path will look like. Able to visualize, everyone? And that's the reason x has to be small, or else you can't treat it like a circular motion. Meaning question got over here. This thing and this thing. Once you got this, question is over. The next page looks very deadly, but all we did was just substitution. It looks complex, but there's nothing there. Is this clear, everyone? So make sure to go through this, especially today. If you see, we did some really good ones. This was a good one. This was a good one. Thermodynamics one. This is also good. This is also good. These things. So we did a lot of different cases today. There are almost half of the problems we did were advanced level today. Last class, they were easy ones. So this was a pretty good one. So make sure to go through this. So this is about springs and blocks and some questions based on different chapters. And don't think SHM end with here. Every chapter will keep coming in one way or another. So next class, when we catch up, we'll continue from here. We will be doing angular SHM. So rotational mechanics will come. Now things will oscillate, angles and all that stuff will come. So we will do that in the next class. So we'll catch up on Tuesday again, as usual at 5:30. We'll continue from there. I think mostly by next Thursday, we'll wrap up the chapter. So SHM will be done by next week. And after that, we'll start off with electrostatics. Okay, we still have time for that. So next week, we'll continue with this. So with that, we'll wrap up for the day. So any doubts, anything, stay back and ask me, or else you're free to leave. And make sure to solve. We have 31 questions here. So should definitely try.